At the Interdisciplinary Stem Cell Institute at the Miller School of Medicine, we are at the forefront of the newest strategies in regenerative medicine, strategies that represent the future of medicine. Using sophisticated science and technology, regenerative medicine is helping to heal or even repair damaged tissues and/or organs. It all starts here. I'm in our state-of-the-art cell manufacturing lab, where Aisha Khan generates the different types of specialized cells we need to conduct research for a wide range of areas. We're also the only ones in the region to have a revolutionary new lab that works with induced pluripotent stem cell. Run by Dr. Stefan Kurtenbach, this unique laboratory is an incubator and an accelerator for new ideas and concepts in the fast evolving field of regenerative medicine.
What we're trying to build here is a think tank for pluripotent stem cells, meaning people with different expertise coming together and collaborate. Research over the last couple of years has shown that pluripotent stem cells are not wishful thinking anymore. We know we can use them to regrow organs or parts of organs. We can use them for therapy. The big question is, how exactly do we reach this goal? It's becoming increasingly clear that working together with different disciplines is really the way to go and to get very hard and important projects done to secure funding and to be successful. We're really now at a tipping point of understanding how we can use those cells, and what recent research has shown that the versatility or what we can do with the cells is really amazing. From regrowing parts of organs or even entire organs themselves is a very important next step to tackle diseases like heart disease. What excites me about this research is that every day we come in, really discover something new, something nobody else has seen or thought about. So pushing the limits of what we know and what we understand is what excites me, and which is why I chose this profession.
The advances made in our laboratories are leading to revolutionary treatments that are already impacting patient care. In cardiology, we've conducted a series of clinical trials over the last 10 years from which we've learned a tremendous amount of information. We're utilizing this information in the design of a new trial that will begin next year that will test the impact of genetics on the response to cell therapy. In neurology, Dr. Dilip Yavagal is using regenerative medicine to dramatically repair the effects of stroke in patients. Using only a tiny catheter, he's shown that an intra-arterial delivery of stem cells directly to the brain can help patients following a stroke.
In my lab, we are really pushing the frontiers of stroke therapy. Stroke brings a devastating burden not only on the individual and their families, but the burden on the health system adds to billions of dollars just on stroke care. It's the 7th leading cause of death in the US, but it's the leading cause of disability in the world. Every patient I see who does not recover in my clinical practice eggs me on every day to change that for the next patient. It made a lot of sense to me to apply the science of stem cells to stroke. And this has been a very exciting journey with a lot of very promising results. What we are seeing is that the stroke size is decreased by 50% or more. This research could make you heal completely and recover all functions. And that's certainly our big hope. So this possibility wakes me up every day and really drives me to make it happen as soon as possible.
Regenerative medicine is also having an impact on our tiniest of patients. Dr. Karen Young is innovating ways to change the field of neonatology and to help develop the lungs of infants born prematurely. Through this remarkable technology, more and more families get to take their babies home from the hospital.
I'm a neonatologist, and that means I am trying to develop innovative strategies to decrease disorders in preterm infants and also to improve their health outcomes in the long term. I personally had a baby in the newborn ICU, and my baby did not make it. But haven't experienced what parents experience in the NICU in a very personal and unique way that I would not want anyone else to experience. I can only say that that has inspired me to continue my work America, despite all the odds. About 10 years ago, we started this mission to find an unique therapy for bronchopulmonary dysplasia. So we decided that we were going to see if we could use these amazing mesenchymal stem cells. And amazingly, what we found was that these mesenchymal stem cells not only increased the survival, but they also prevented the long-term deleterious effects of oxygen on the developing lung. Amazing. So our work and others have contributed to now clinical trials that are ongoing with using mesenchymal stem cells to alleviate chronic lung disease of prematurity and indeed to improve their long-term outcomes. You can think out of the box ideas and move them in the box in our patients.
Our dedicated team of interdisciplinary experts is pursuing cutting-edge concepts that will lead to life-saving cures and improve the health of humanity. We look forward to partnering with you to continue developing this revolutionary and life-changing medical technology.